Okay, so welcome to another OWASP Signet Night. Today we got a great presentation from one of our own, Michal, who is talking about modern authentication, FIDO2, I think it's pronounced, and Passkeys. As you know, last month I sent a message asking for volunteers to take over the chapter and form a new committee. We got 3 years period to serve. You can continue if you want, but 3 years is quite a lot to serve the community, which has been great. I'm not complaining, but I'm looking forward to the new 3 guys taking over. We got 3 nominations. Now, OWASP sponsored 5 positions for chapter leader, so 3 is within that realm. So what we are going to do is next month in the AGM, we're gonna ratify them, and then we just hand over the stuff to them, and they can take over from them. So this technically is the last, I don't know what to call it, meetup that this committee will organize. Obviously, the AGM will be the last one, but the last talk per se. So I don't know if you saw the email I sent around, but the 3 nominations we have is Blair Hudson. I'm not sure if they're here. Forgive me for the pronunciation. The Barkaya Dasgupta.
Yeah, that's.
Okay, one of the lucky few. And forgive my pronunciation. Nickleby?
He's here. Yeah,
Nickleby Tang. Okay, well, there you go. He's going to be one of the future guys standing up here. All right. As I said, AGM will be hosted on March, probably mid-March. We don't have a exact date yet, but it will be in the meetup as usual, so just keep your eye open. It's going to be in the secure closed border facility, so it's going to be that terrace. I don't know if you went to a Christmas party. It's quite nice. Nice view, nice barbecue. Good place to have it. Okay. If there are any points that members want to raise during the AGM, please send me an email, break.campo@owas.org, and we will discuss it during the AGM. Now, something I have been told to remind you is that the toilets are outside past the lift on the left, right? Okay. All right. Any questions, concerns, queries? Cool. Without further ado, give it to Michal.
Okay, thank you, Rick. Hello, everyone. I'm Michal Kepkowski. I'm currently doing PhD at Macquarie University. And yeah, I wanted to talk to you about modern authentication, FIDO, and Passkeys. So very briefly. Okay, about myself. So here is how you can contact me, reach me on GitHub or LinkedIn. But my background basically is software development architecture. I am SME, co-founder of Identity First Group. This is like a small identity group of people that we are implementing some standards. I was contributing to IAM projects, and hopefully in July I will graduate with my PhD. I was also a speaker at Identiverse, and this year I'm doing the same, Sydney meetups as well. Okay, so let's go to FIDO. So today agenda, I'm just going to give you the overview where in the IAM we have authentication and the FIDO. We'll go through the intro of the FIDO, how the flow works. It will be a bit technical. I promise I will try my best to explain this. I will talk about the authenticators, about the support that we have right now for the FIDO protocol, something about certifications, about the considerations, not only security, but privacy, usability, deployability, adaptability. And at the end, we'll touch the passkeys. Okay, so I wanted to show this big picture, complex picture to show the IAM architecture, the example of big IAM architecture, to show you different elements like IDM, access management, privilege access management, directories, secret management, applications. But basically the IAM, the FIDO IAM sits in this authentication federation part where we have some identity providers and we have the authentication there. Usual, of course. So regarding the FIDO, FIDO is Fast Identity Online. This is protocol which is based on two protocols actually. So it's kind of named for two protocols: web authentication, which is written by W3C, and they are maintaining it, and CTAP, which is the FIDO Alliance. And we have three parties in the protocol. We have a server, we have a client, and we have authenticator. And this is how it works. So basically, between the FIDO server, FIDO client, we have web authentication protocol. Then I will later explain what does it mean. It's just like position where we have what. FIDO client and talks using the CTAP with authenticator, and we have obviously user. So just examples: FIDO server can be your application. FIDO server can be your IDP, identity provider, like for example Google or AWS. FIDO client, it can be your browser, it can be your phone, it can be some native application on your PC. Authenticator, it can be like USB token, it can be also your phone. Okay, any questions so far? Because I think that I'm going fast, right? Okay, so now let's go a little one step lower. So I'm very sorry that this flow starts from the right side, but I didn't have time to fix it. But we have the user which initiates the login or registration flow. This goes through your client. Let's talk about browsers in this case, which goes to the FIDO server, which can be integrated with your application server, for example. And here, actually, the FIDO protocol starts, where the FIDO server generates the random challenge, which again travels through the client to the authenticator. At this stage, we have user action. And now user action can be user presence or verification. I will talk about this later. And then in the authenticator, we have a cryptographic signature created over the challenge. And this message goes back through the client to the server where the signature is checked. So it is a very simple schema, like challenge and response. Any questions to this flow?
Okay, is there an offline mode that works with this scenario?
Yes and no. So basically there is, but it is accomplished through the extension of the protocol, which is based on generating HMAC secrets. And for example, Windows is doing it.
Because I could see there's a lot of interactions going on, so I can imagine the traffic flow.
Mm-hmm.
How well does it scale in terms of the deployment? Like, can it handle, like, for example, you may get 1,000 requests?
Yeah, so basically the FIDO server, what it does, it generates the challenge, right?
Yeah.
And it verifies the signature at the end.
Yeah, but how well does it scale? It's like, that's the question.
This is one request and one response. So, I mean...
Okay, no problem.
Can we have a FIDO server clusters, which can probably...
Yes, of course. Okay.
We can have that.
Okay, so I will go even deeper now. So we have like detailed view how it works, right? So first of all, let's say that we are discussing the web flow, and we have connection between FIDO server and the client. Let's say the client is a browser. So here we have some kind of challenge, secure challenge. So specification doesn't define that you have to use HTTPS and REST calls, for example. You can use whatever you want. The thing is that the challenge has to somehow come to the client. And inside the client, like you take the browsers, the web authentication API gives you two functions in the navigator object that you can call and do either registration or authentication. There are basically two methods defined for that. And what happens inside the client, so implementation, for example, of Chromium or Chrome, this call is translated into the CTAP protocol. Now, the CTAP protocol is like a very low level how to make binary messages to the authenticator. It can go through the USB, it can go through Bluetooth, it can go through NFC. So here we have like these options to select. And also one important thing that here the origin of the request is added. So basically in the web scenario we have the domain. Okay, and here we have the registration. So the challenge goes through the client to the authenticator. And now in the authenticator, we have a few actions. First of all, this user presence or verification. User presence means that basically we are checking that we have a human in front of the computer. So basically, in most cases, it will be touching the button. Or verification if you have PIN or fingerprint or face scan. These are the mostly used. But if you go to the FIDO specification, you can find all the possible biometrics that can be used for verification. Okay, at this stage, the private and public keys are generated. The private key is saved in the authenticator. The public key will travel to the FIDO server. And at the end, we have the assertion, basically the signature, and also attestation. And about attestation, I will talk a little bit later. And now all this, the signed response together with the public key travels back to the FIDO server where the public key is registered. That's it. Yes, question.
Quick question. Is it possible to use FIDO2 without user verification? Is it possible to have a
Yes.
hardware token that just responds automatically?
Automatically, yes and no again.
Yeah.
So yes, it is possible if you just call the setup. So for example, you want to implement your own native application, right? So you kind of building the client. So if you build the client, you can just use setup, and in setup, yes, you can do like this is called silent authentication. So basically, nothing needs to be done. The authenticator just needs to be put into your computer.
In my case, it's a web application, but it also has an Electron app.
Okay, now the web application.
Yeah.
So in the web application case, you are kind of relying on the implementation of Chrome, for example, right? And implementation of Chrome already, well, it depends how you implement this. But again, if you just implement in JavaScript, then you have to use the web authentication interface that Chrome implemented. And this implementation prevents you from doing the silent authentication.
But like in Electron or something, I could probably use CTAP directly.
Yeah, if you, for example, implement some plugin in Chrome, then yes.
Extension or something.
Yes.
Yeah.
Yes.
Cool. Thanks.
Okay, now the authentication. Basically, it's the same. The only difference is that we are not generating the keys here. And in response, we have the signed response. And because the FIDO server already has the public keys, the signature can be checked. And we know that this guy is in a possession of this key. Right? Any question? No? Yes?
So FIDO, so like, are there separate instances for each application, or is there like universal FIDO2 server?
So one server can have multiple registrations, and registrations are per domain. So basically, if you have different applications in different domains, then yes, you have multiple different registrations. And the same happens in the authenticator. So for each domain, you will create new keys.
What do you mean by origin? Like you said that during the key generation process, there would be an origin which would be also attached.
Yes. So here, during the this phase in the client will add the origin. So if you're logging from google.com, the google.com will be added here. It will be saved together with the private key. And actually, during the authentication, it will be checked here, but I wanted to show you this later.
Does it protect against spring biotech? So if the client,
Yes, because the challenge is random.
but if I capture it, the client, can I set up a separate session by quickly sending through a reply?
If you
I'm just asking.
here, right? Yes, of course. But for this, you would need to have like,
You'd have to be.
yeah, you have much bigger problems if you can do this.
Fair enough.
Yes.
You have certain requirement for browsers, which browser it is, because are we assuming that all browsers can access the USB and authenticated device, the hardware device?
Yes, I have a slide about the support, but most of the modern browsers are supporting it.
And the authenticator in that FIDO model,
Yep.
Does it have to be always a hardware token?
No, and I will show it as well. There was a question here? No? Okay, let's go. So now I just wanted to give you like idea about the passwordless and what does it mean and what I understand under the passwordless, because I've seen a lot of different definitions. So let's examine the password-based flow. So we have the username credential goes through the browser goes to the server, simple. So we have authentication and verification at the same like channel, right? Going through the internet actually. Now in the passwordless flow, we have these two split, and verification is local. So basically your authenticator verifies you. So it's, for example, PIN biometrics. And then after this, the information goes through the internet is simple assertion. So it's signature, for example, over some data. So there is no password here. And by no password, I mean no OTP, no like it's secret, I don't know, token or anything. There is just the assertion over the randomized challenge. Yep. Yeah, so regarding the authenticators, so yes, there can be the roaming authenticators, and these are the ones that we can just take and put in every device. In most cases, are these hardware USB-like tokens. Some of them support fingerprint, some of them not. We also have the platform authenticators, so they are usually embedded in the device. You cannot remove them. They are based on trusted environment or TPMs. And yeah, verification depends on the platform. So Windows Hello for Business has it, for example, but you have to have a laptop that supports these various methods that they verify you. Android from 7 Plus, I think that has, and iOS as well, the latest versions. Anything about this? Any question?
So I presume that it will be the kind of a private key. So is there any chance of like having more than one user? Let's say in an instance of you lose a device or a key.
Yes.
So is there a way to like enroll something else as a backup?
Enroll something. I'm not exactly getting the question.
Kind of like let's say that we have YubiKey.
Yes.
Kind of thing. So we lost the device.
Yes.
So there's a chance of having another backup device or something like that.
Oh, I mean that if you can register two devices to the same user account,
Yes.
something like this. Yes, of course, you can.
But that's only if the application supports it, because some back-end systems have seen only have one key, only support one key.
Yes, sure. True. So, but this is up to the implementation of the FIDO server. It's not up to the protocol itself. But yeah, technically you can do.
Is it possible to enforce that the keys are not exportable and not roaming?
Not exportable and not roaming. So in general, the idea of the FIDO is that the keys are not exportable.
Okay.
Now then actually, but the Passkeys changes this. But but if the platform can be not exportable, yeah, they should be.
Yeah, and so not roaming. Is it possible to say I only accept TPM credentials?
If you can do it from the server side, you mean? Because on the server side, you can implement the policy yes, of course, yes. There in the protocol, there are flags that like identify that this is platform authenticate and this is
I
from
had
you.
the impression the answer was yes. I just wanted to get
Okay. Anyone else?
How long ago FIDO2 was developed actually? Is it like 5 years?
So the thing is that they implemented first U2F protocol, and it was more than 5 years ago, definitely. And then they switched to the FIDO2, which is like the second version of the protocol. Yeah. Like U2F was not very widely supported. Okay, I just wanted to also tell you that on the market there are different kinds of authenticators. So like, for example, Yubico is doing a lot of different protocols inside. I don't know if you can see, but PGP, TOTPs, PIV, and yeah, some other config sets that you can set it. So basically, it's not just limiting you to the FIDO. If you have on your architecture already some authentication protocols, then there are some mixtures available, and also non-USB tokens. If you are used to like smart cards, then there are also kind of smart card-like devices. Okay, yeah, so this table regarding the support. So as you can see here, we have different operating systems, and here we have the different browsers. So most of them, the modern ones, support FIDO. And basically support FIDO means that they give you the API, and then they somehow integrate with the operating system. So for example, in Windows, when you trigger the FIDO API in your JavaScript, then it will trigger Windows Hello in most cases. But like for, I don't know, for Linux, it will simply execute the native implementation of the browser.
So are these invoked using some browser extensions, or?
No, these are not browser extensions. It's like browsers developed this code. So they are like native in the browser code. So if you go, for example, for Chromium source code, you can find the FIDO implementation there.
So the operations are really human-centric. So like the focus is on people authenticating. Have you explored like physical security measures with this? So using this as an alternative, as like you have NFC, like against
entering the building, for example.
Yeah.
Well, I haven't explored this, but I've seen the companies that are doing this.
Okay,
so
yeah.
I think that it's happening.
Using FIDO2.
Yes.
Oh, cool.
Yes.
Sorry, so in the case of Windows Hello or any other device, I think the assumption is at the time that I set it up, we will record the device ID, and we also record the username that has logged in.
Could you repeat? Like, I'm not getting the question.
So when I pop up the Windows Hello, when I enter my PIN, what would you communicate back? Is it the device ID that I'm using right now, and also the username that I've logged into the Windows? Is it the two factors that?
Assuming that you are executing the FIDO transaction, right?
Yes.
So basically, it works exactly like in this screenshot. So basically, the challenge is sent to your Windows Hello, which has its own implementation, how to deal with like TPMs, for example, in the hardware. And in going back, you're getting the signature over the challenge. Yeah.
Right. And the signature contains?
Well, the signature contains the challenge. What else is there? In attestation, you have some kind of device parameters, like TPM, for example, parameters, but it is for registration.
It's like you should just broadcast the public key, right?
Sorry?
I'm saying that it's just broadcasting the public key, isn't it? Like doing the authentication or something.
No, it's not broadcasting public key. The public key is only once sent to the server during the registration.
Oh, okay.
And then during authentication, basically just the digital signature is created in your authenticator, and the signature is sent back to the server, and server just using this public key verifies if it matches. Okay, I wanted also to tell you a little bit about documentation, because if you take other like passwordless or crypto-based schemes, there is practically no documentation, no user guidelines, how to do it, how to implement it. So at the bottom, I just put the specifications that we have, but there is a lot of materials regarding how to do different stuff. Like, for example, how to show the authenticator metadata, or what are the security requirements to build authenticator, to build the server, how to do onboarding, how to do justifies different security choices in the FIDO. Then FIDO Alliance also giving you the certification. So they are trying to certify the servers, authenticators, biometric components. And above that, you have the white papers, guidelines, UX guidelines, and use cases. So basically, especially for the like first deployment where you are trying to figure out how to do it. So they really doing a good job, and people from big companies are really contributing. This is everything is free, so you can just go to FIDO Alliance and find these resources. Yeah, one slide about the certification. So there is a certification program, and probably you've seen this kind of sticker in different products. So the only problem is that there are 3 levels, and most of the authenticators are in level number 1, which is interoperability and functionality, some basic security checks. So if you have this FIDO certified, it doesn't mean that they're super secure. It means that basically it works with the FIDO. And this is voluntary, so not every vendor has to do it. Okay, a little bit about attestation. So imagine that you have a server and you want to limit the authenticators that you allow to be used. So manufacturers can actually embed the certificate to the FIDO authenticator during the manufacturing process, and then during the registration you can ask for this attestation, and you will get it together with the response. Now there is also a metadata service. This is like the API that FIDO Alliance provides that basically publishes the public keys for these manufacturers. So you can just call it and take to your server and then verify attestation. Now the problem is that because FIDO is doing the privacy by design, they do not allow to embed these manufacturer root certificates to every device separately. So there has to be at least 10,000 devices with the same certificate, so that you cannot track people. Because otherwise you could just do the attestation check that this is this guy, and you can track the people. Now, however, for the latest version, CTAP 2.1, they introduced the enterprise attestation, which means that you can collaborate with the vendor, and vendor can put your own certificate there, and this way you can make the policy that, for example, only your employees using Yubico's that are on the market, but you can check that this Yubico was bought for your company. Any questions to that? I need to drink.
What kind of companies are you saying using it?
Which this attestation, or you mean enterprise attestation?
Well, yeah, the enterprise service.
The problem with enterprise attestation that is very new. So even if I talk to Yubico, it's kind of like process that it's not exactly clearly defined how to do it. Yeah, and regarding the attestation itself, yeah, I saw the implementation is in the most servers. So even like, for example, go to Azure AD, you enable FIDO, you can enable attestation there.
Cool. So what is the current percentage adoption, like in terms of transition from a regular multi-factor authentication to your FIDO solution?
What is the rate of the transition?
Yeah, so what is the current adoption percentage of FIDO-based solution vis-a-vis multi-factor authentication, the regular one?
I have no such information, but from what I've read in different companies, like I think Windows, Microsoft, and Gluu and Cisco provided, so there is like, well, a few percent.
So they are pushing it. My question is that
yes,
the enterprises are actually adopting that.
Well, there are a lot of problems with this adoption, and I will discuss them as well. Okay, so quickly about the authentication methods. So I guess we all know the passwords and memorized secrets alone are the problem. There is many issues. There are some out of band 2FAs like OTPs, email, SMS, voice, OTPs. Then we have these delivery channel issues that I will also present. We have generated 2FAs, some TOTPs, HOTPs, or push notification, which is not generated, but it's kind of triggered. But then we have also authentication channel security, and we have this crypto base, which I kind of put it as a best, but then we have all the issues with usability, deployability, adaptability, right? Okay, so why should we even care about it? So last year there was like a lot of fuss about that big companies that have MFA and they were still hacked because somehow this MFA was bypassed. So I just listed here two examples of attack. First is the phishing and adversary in the middle. So this is actually this picture. So the idea is that first of all, we have some phishing campaign. The adversary is sending the phishing emails to our victim, and our victim opens the link, which forwards it to the evil proxy. Evil proxy, if you don't know, it's basically just the proxy, which is evil, which means that. But the point is that basically the SSL connection is terminated. An evil proxy can see everything in the plain text, right? So and the evil proxy will serve all the content from the genuine server. So when our victim accesses this page, it will see, for example, login page of Microsoft, right? And let's say this our victim has some second factor like the push notification. So first of all, the credentials will go through evil proxy will see the credentials. Then we have the trigger for the push notification. Now the push notification will go out of bounds. So basically this path, right, to the phone of the user. And even if there is some kind of verification, some number or some additional data like I don't know, what can be geolocation, for example, here, it still might match with what the user sees on the screen. So when the user confirms the authentication, then the session is created on the server, and this session somehow has to be sent to the browser, which means that it goes through evil proxy catches the session and can impersonate the user. Simple? Cool. And the second attack is MFA fatigue, so it's even simpler. So basically, the adversary is trying multiple times to trigger the MFA factor and hopes that user will accept it. It can be also connected with some social engineering that they are calling him and asking that we are doing testing, please accept, and done. Okay. So now how the FIDO prevents this? So first of all, FIDO is in the channel of authentication. So it's not like it was with the push notification or OTPs that we have additional channel. It is actually in the channel of authentication. So if you register in the genuine page, the registration will be under the domain of the real domain. Now the adversary to make it work, it needs to make slightly different domain, right? It has to be able to register the SSL certificates. The phishing domain will be similar but different. That's why when we have the FIDO authentication, the FIDO authenticator will check this origin, and this origin won't match the origin that is saved on the authenticator authentication phase, and that's it. Yeah.
How would this work with an enterprise man-in-the-middle proxy where they're encrypting their impersonating website? Firstly, are they in the wild very much these days? Because I have seen. But
if you register with this proxy, then it's fine.
Yeah, as in it's in your root trust or whatever. Like so that's fine. It won't break the FIDO2 transaction.
Well, FIDO2 doesn't check if the page is trusted or not. It doesn't check the SSL certificates. It just matches the domain name.
Right. Yeah. Okay.
What about if you spoof the domain name on the return, on the response on the server? I mean, if you are in the evil proxy, right, you can change the return response. You can put the right domain so that the client will receive the right domain.
So it's up to client implementation, because the client is in responsibility to put the proper origin. So I have no idea how to do this, but
most browsers would fail that because the SSL certificate wouldn't match
the
domain.
But is it SSL certificate also checked in the response? Matching, like spoofing. But then the question is which origin is taken. So will be the request.
Will you be able to change all the headers in the request? You can even change the whole packet.
No, but you're requesting from the browser, so this part is
Yeah,
not
that way.
malicious.
But remember, you're going through the EU proxy, right?
Yeah.
So the EU proxy can change the request anyway it wants.
Yeah, it can.
So
But then you have the URL that from client to the server, right?
Yeah.
So this one has to be different.
Yeah.
And this one is checked.
Yeah. From that way, that. So we'll have to have an SSL between client and proxy, and then proxy to server, right?
Yes, it is.
Yeah, we agree. But I'm not talking about that channel going though. I'm talking about the return channel.
Mm-hmm.
So you can configure the proxy such that the response is altered and it looks like it came from the server.
Yes, but it's still in the request of this domain, right? And you have SSL check. So
yeah, we'll fail the SSL check.
Okay, cool. Yeah, so now about the usability. So security is nothing about the usability, and actually the authentication is rarely the task. So basically people go to do something, not to authenticate. And in that case, like passwords are really good because there is no device required, there is easy, cheap, scalable, technology independent, non-technical creation, actually privacy preserving, if you think of like hashes, for example, storing database. Perfect matching is required, unlike biometrics, for example. Non-digital store, only in our mind. Simple UI, UX, so basically 2 fields you have to just provide, and people know this already. Now in the FIDO, they are really trying to make it also as usable as possible. So for example, when you have your phone, they integrated everything with the way you unlock your phone so that people know how to do it. Also in terms of like implementation, so they are providing even icons and US guidelines, text, what should be said to the user, so you don't have to think when you are implementing the authentication via FIDO. Yeah, so basically, but there are some usability and implementation issues. So actually, this was my latest paper. So I did like user study in terms of asking identity specialists, implementers, deployers, like what are the issues. And obviously the account recovery is the first issue that we have, because the keys are not exportable. Then we have the problem, if you lost the authenticator, what should we do? The guidelines are that you should have multiple authenticators registered, but obviously this is not a good solution, and it's also a costly solution. So you can also do some kind of like combined multi-factor authentication that has the same security level, which is also like hard to actually do. You can do some vetting of users, I don't know, liveness checks with face match, something like this. But basically, this is then an issue, the biggest issue. But also, if you can see something, I guess, easy to do, like enrollment is also high, or self-management is also high, or how to provide the authenticators to users that are remote. Like how can we know that this authenticator is good and this user will use this authenticator? The provisioning, which is kind of for me easy, but yeah. Privileged accounts is also a nice use case. So how can you give access to some, for example, root machines that is time limited and is also based on FIDO? So yeah, delegation, for example, how can I delegate my account to someone else? Yeah, so there are a lot of challenges actually with FIDO. Any questions?
Any solutions?
Yeah, so one of the solutions is actually what Passkeys introducing. So first of all, Passkeys is kind of marketing term. So we want to remove the passwords. So let's give people something that kind of sounds the same, but it's different. It's Passkeys. So, but technically these are the discoverable FIDO credentials for passwordless authentication. What does it mean? It means basically what is on this picture. So we can have single device, we can have roaming authenticator, we can have platform authenticator. It's just requirement that it is discoverable, which means that you don't have to provide public keys to the client. It kind of runs automatically. And one more feature was added, the multi-device. Now the multi-device is presented here. So the idea is that before in the FIDO we would have this device with this key and this device with different key, key B, for example. So what they've changed is that they allowed to this private key to be attached to the account. Now, this is not in the FIDO specification, and they didn't specify how to do it, so each vendor can do it their own way. However, because this is kind of, now we have the key that can travel everywhere, so they also introduced the device-bound keys. So this is kind of to identify different devices. So if you do the migration to new device, this new device can send the signature of its own key, so that server knows that new device was initiated and new verification can be done for this device. Now, of course, this doesn't solve the problem of migration. It just elevates it to the next level to, for example, vendors of devices, but it kind of solves the issue for regular people, because it kind of works like the password managers that you have on different devices. They're sync. So the same way these keys will sync, right? However, this kind of changes the principle of FIDO, because now we have the private keys that are exportable. So if you want, there are like 3 choices for you. Of course, we have the password, OTP, this is like a security line. So we have these multi-device passkeys that are the key is bound to the account. And then we have a bit stronger approach where we have these device-bound keys, so we can check which device is used to the authentication. And of course, we have this old-fashioned FIDO where the key is only in the authenticator. And in the protocol, you can detect this, so you can see what kind of authenticator was used. Yeah, and if you want to know more, I wanted to also show you that there is YouTube channel of Identiverse. There is a lot of talks from last year regarding like what are the new things in the FIDO, and it's also open and free. Okay, last thing before the Q&A. I have 2 announcements. First one is that in Macquarie Uni, we are doing this kind of one-day workshops and presentations with the mixture of presentation from academia, from cybersecurity, of course, and industry. So there are like kind of 4 tracks in terms of data, technology, people, systems. There will be some kind of security, privacy mixture, 20th of April at Macquarie Uni. And we are inviting any presentations from industry. If you have any like research, innovative approach to do something and you want to share, then yes, we are happy to hear. This is one. Now, the second is also that this week the TAFE NSW ran the project IATD, which is Institute of Applied Technology Digital. And these are like the micro credentials, 6 weeks of sessions, face-to-face sessions, where we have some kind of laboratories. We have different topics, online content, laboratories, we have face-to-face. From the cybersecurity, we have digital forensics, identity response, AI security, and I'm teaching basics of identity and access management. So if you are interested and want to attend, I think it's for free still. So you can enroll. It's just 2.5 hours per week. Okay, and this is it. Thank you. Questions?
With that idea of passkeys, I'm just wondering about blast rating. So if I use Google as my host for my passkey, if I get locked out of my Google account, I could end up being locked out of anything that I've used that passkey with to log into. Would that be a fair way of looking at the risk of with passkeys?
Well, it's risk of using FIDO and hardware authentication in general, right? Passkeys only just gives you like this additional way to recover your account.
So it just makes having those backup codes and everything for But
Yes, it's
how
still going
much
to be
even more
there.
important because
Yeah.
that blast radius does exist.
Yeah. So that's why I said that it's kind of not solving the issue, but kind of moving this issue in the different place.
Don't lose your key.
Don't lose your key, yes.
Yes?
Bit of a naive question, but like if FIDO was implemented on a device that had the passkey like inbuilt into the device, and there was access to the website, does that mean like you can just remove like the login portal and then when they log onto the website it automatically logs them onto the user profile?
I'm not sure that I get it, but basically, you can remove the regular login page, yes, because if you are just triggering the FIDO authentication, then kind of in case of phone, it will just pop up this authentication pop-up and you will do a fingerprint. It doesn't matter if you have passkeys or not, but
Like
kind of,
Face ID or something.
yes, or Face ID.
So that can work for the whole internet, every website adopted FIDO, right?
Yes, it would, but I don't see this coming fast. Any more questions?
Do you see any kind of a trade-offs with the introduction of this exportability of the keys, like a duplication of keys is possible then, right?
Mm-hmm.
So what kind of a trade-offs in security that you foresee, like going forward, might have happen because of this?
Well, first of all, it has to be, I mean, for the regular people, like for the public use case, I think that they had to do this because otherwise it was not usable. Because you would just, if you have the at scale, thousands of users, you cannot do the recovery in a secure way. So they had to, and in terms like if you have really the sensitive use case that you cannot allow exporting the keys, then yeah, then you have it. You have to deal with it.
And coming back to, I think, his previous question, so in terms of scalability, like if you are really having humongous amount of loads coming, like the requests are coming into the FIDO request, so probably one single compute is not good enough. So how would you really manage the clusters of the servers or FIDOs, how they interact with each other like that?
So again, the FIDO server talking to, for example, browser, you can implement it as a REST code simply,
No,
right?
like,
So we can scale it.
okay.
This server like any microservice, for example, right?
All right.
You need a server multiple locations anyway for developers. So
On the server side, what are the requirements there? Do you need TPM on the server side?
No, on the server side, no. On the authenticator side.
Yeah.
On the server side, you're just storing the public keys. So even if you have data leak, then it doesn't matter.
So the foundations that you said, like the FIDO servers, they would have, let's say, multiple rows populated for individual requests, right? And let's Google.com, then X, then Microsoft.com, X, something like that, right? And that basically already map with the entity, like which is actually the generating whoever is generating. So that's how it is.
Yep. Exactly. I have even, I took some examples if you want to like see different tokens of different vendors. So as you can see, they vary. Yeah. So yeah, there are very different ways to do it in terms of like shielding or casing. Yeah. And also interesting thing is that basically they have very limited number of keys, like Ubico, I think has 25 keys to be saved on it. So if you reach this limit, then yeah. So if you want to see, I'm giving it here. No, these are like This is not my private. It's just a presentation.
Isn't that passkeys for the delegation problem?
If the passkeys solve the delegation problem,
can you delegate a passkey to somebody for temporary use?
Interesting. Well, technically you can do this, right? Because if you log in on this second device and you go through the verification process.
Portable, which is the same copy of the key, right? So
it is.
How can you expire that after, say, like I want to give access only for a month? I can't expire that key.
Yeah, I have no idea. Maybe it can be done on the level of vendor, but I have no idea.
Isn't it a real practical issue that if it really wants to, this system really wants to become a mainstream, 25 accounts is not practical. Of course, maybe
Well, yes and no.
that
Actually,
is a challenge of more devices.
yeah. So I give you the idea example from Yubico, but I think the FIDO2 has 100 something keys, so it's not like it's very limited. Platform authenticators actually don't have, I think, any limits because it's kind of stored on the device. But also, if you are thinking of federation and you have like one IDP in your company or one IDP like I don't know, Facebook, then it's kind of one key only registered, right?
Any form of attacks which you think is still feasible, like mechanical MIKM attacks against these form of security checks, which can still go through the FIDOs? Or like you have probably encountered some of them, experimenting with some of them already. Like what could be the attack surface for this? So probably like maybe some sort of man-in-the-middle attacks could be possible. Not sure. Yes. Thank you.
Nothing.
I suppose it's something that you could give it a crack, see if you can.
I mean, so basically, if you think of like breaking the authenticators, yes, there are some few like papers on this how to break authenticators. There is a paper regarding the TE of Samsung, for example, which they show that also the key is recoverable. So yeah, but in terms like breaking the protocol itself, not the implementation or hardware, then I haven't found any. There is also the one that someone mentioned regarding that if you have access to the client and you can do something in the client, then yes, you can, for example, switch the keys or register your own authenticator.
Yeah,
but it's not on the protocol, actually.
Yeah, that's right. See, I mean, one challenge is that if that hardware is kind of currently doing some sort of digital fingerprint, or I mean, that is used as initiator of that authentication.
User verification.
So by any reason, like if that device is compromised and there are some other sort of authentication which you have the origin for that, again, probably that will still not work, or does it work? Like I'm saying that, let's say that device itself is it the FIDO client now, like that device itself?
Device itself is authenticator. The client is the browser or your mobile phone, which plays as a client.
So if I say that if that device is compromised,
if the client is compromised, you mean? So through the client, we have traveling the challenge, and we have the signature that travels, right? So the challenge is random and kind of gives you nothing, because if you change it, then basically the verification on the server side would fail. And the signature, well, I mean, if you break the crypto, then you break the crypto, but
that's too much.
Yeah.
Okay. Sorry, you got a question?
Yeah. So, how do you compare FIDO2 with FIDO2 with SQRL? SQRL, Squirrel protocol, which has same sort of. Are you aware of?
No, I'm not.
It is almost similar to.
Okay, but it's also like web kind of based?
Yeah. Same public and private key based.
Yeah, okay.
It has some additional variations on top of that, where those private keys get tied to the master key of the user. Some more additional keys. So that protocol, I'm actually learning about that, so I'm just comparing.
Okay, cool. Yeah, I think that FIDO kind of like they managed to collect all those big guys and force them to implement it, and that's why it kind of moves forward.
All right, if I might interrupt, great presentation, great questions. Thank you very much. It's just the pixels have arrived. They're down there. And they're getting cold, so I assume you guys want to eat and drink. So let's give a clap to our very good speakers. And feel free to approach him and ask him a million questions. So he's here for a while. So yeah, just go and grab some. Oh, I forget